Ancient and Classical Period, 6000 BC to 500. Introduction. As early as 40,000 years ago, humans were making tally marks on wood and bone as means of counting. They undoubtedly had a rudimentary sense of number and arithmetic, but the history of mathematics only properly began with the development of numeral systems in early civilizations. The first of these emerged in the 6th millennium BC in Mesopotamia, Western Asia, home to the world's earliest agriculture and cities. Here the Sumerians elaborated on the concept of tally marks, using different symbols to denote different qualities, which the Babylonians then developed into a sophisticated numeral system of cuneiform characters. From about 4000 BC, the Babylonians used elementary geometry and algebra to solve practical problems such as building, engineering, and calculating land divisions, alongside the arithmetical skills they used to conduct commerce and levy taxes. A similar story emerges in the slightly later civilization of the ancient Egyptians. Their trade and taxation required a sophisticated numerical system, and their building and engineering works relied on both the means of measurement and some knowledge of geometry and algebra. The Egyptians were also able to use their mathematical skills in conjunction with observations of the heavens to calculate and predict astronomical and seasonal cycles and construct calendars for the religious and agricultural year. They established the study of the principles of arithmetic and geometry as early as 2000 BC. Greek rigor. The 6th century BC onward saw a rapid rise in the influence of ancient Greece across the eastern Mediterranean. Greek scholars quickly assimilated the mathematical ideas of the Babylonians and Egyptians. The Greek used a numerical system of base 10, with 10 symbols, derived from the Egyptians. Geometry in particular chimed with Greek culture, which idolized beauty and form of symmetry. Mathematics became a cornerstone of classical Greek thinking, reflected in its architecture and even philosophy. The almost mystical qualities of geometry and numbers inspired Pythagoras and his followers to establish a cult-like community dedicated to studying the mathematical principles they believed were the foundations of the universe and everything in it. Centuries before Pythagoras, the Egyptians had used a triangle with sides of 3, 4, and 5 units as a building tool to ensure corners were square. They had come across this idea by observation and applied it as a rule of thumb, where the Pythagoreans set about rigorously showing the principle, offering a proof that is true for all right-angled triangles. And it is this notion of proof and rigor that is the Greeks' greatest contribution to mathematics. Plato's Academy in Athens was dedicated to the study of philosophy and mathematics, and Plato himself described the five Platonic solids, the tetrahedron, cube, octahedron, dodecahedron, and icosahedron. Other philosophers, notably Zeno of Elea, applied logic to the foundations of mathematics, exposing the problems of infinity and change. They even explored the strange phenomenon of irrational numbers. Plato's pupil Aristotle, with his methodical analysis of logical forms, identified the difference between inductive reasoning, such as inferring a rule of thumb from observations, and deductive reasoning, using logical steps to reach a certain conclusion from established premises or axioms. From this basis, Euclid laid out the principles of mathematical proof from Axiomatic Truths and His Elements, a treatise that was the foundation of mathematics for the next 2 millennia. With similar rigor, Diophantus pioneered the use of symbols to represent unknown numbers in his equations. This was the first step toward the symbolic notation of algebra. A new dawn in the East. Greek dominance was eventually eclipsed by the rise of the Roman Empire. The Romans regarded mathematics as a practical tool rather than worthy of study. At the same time, the ancient civilizations of India and China independently developed their own numerical systems. Chinese mathematics in particular flourished between the 2nd and 5th centuries AD, thanks largely to the work of Liu Hui in revising and expanding the classic texts of Chinese mathematics.